we have something that's called a transfer, which also called activation function that we saw in here. So we have three types for it: hard limit transfer function, linear transfer function, and sigmoid function. So for the hard limit, if the net input value n is above a certain threshold, the neuron become active. Otherwise, it's inactive. So let's say here it's x. So we will check it with here. For example, we have it either 0 or 1 or 1 or -1. For the linear, the activation increases linearly when with the increase of the net input signal n. But after a certain threshold, the output become either a value, like a specific value, for example 1. For the sigmoid, it's like in the shape of an S. So here, this line wouldn't go forever. So let's say it will like have a specific limit. Let's say we got here a 7. It will still be a 5 because the limit is 5 here. In the sigmoid, the f and the sum are the same. So let's say the sum is a 3, the f is a 3, 10, 10, and so on. So let's say here, for example, we have this problem where we have two types of fruits, orange and apple, and we have a sensor for the shape, texture, and weight. After it goes into this sensor, it checks whether it's apple or orange, and it will go to other sorter. If it's apple, it will get it in this box. If it's orange, it will get it in this box. So this is just an example here. Sensor has three properties with them, and the fruit will be represented by shape, texture, and weight. So the orange will be 1, -1, -1. The apple will be 1, 1, -1. So for example here the shape is round, and so on. So we have a very important question here, is that how the neural network learn. So we have two types of machine learning. We have supervised learning and unsupervised learning. If we go to supervised learning, let's say we have these inputs T, H, and C, and they have different weights, and we have here, for example, the output for them. So we can we have this table. We can check every input and see that it is, like, for example, is this output the same as the target one or the predicted one or not. So let's say we checked this one and it is the same. We check the second one, it is the same, but we check the third one, this is just an example, it is not the same. So our target output was not the same as the actual output that we got. So this means that we have what? We have an error. So the error is the way that we calculate it is the target output here minus the actual output. Target output minus the actual output. So using this error, we will modify the weight here, that we will reach to a weight that will get us most of the cases correct, with correct results. What does correct result mean? It means that the actual output is the same as the target output. So we will divide our data 70%, for example, for training and 30% for testing. This could, the training could be more than 70%, it's fine. But the actual idea of this is that when we do the testing, we just want to check if the output is correct or not. We will not modify the weight through testing, only through the training. Okay, so as we see here, for example, they put the training 85%, 70%. The main idea is that we will modify them in the training to check them in the testing later, but we will not change them in testing.